Hey guys, so I'm going to go through our review for Math 3 quiz, our first unit. The first one that we're looking at is find the key features of each graph. So we're given this quadratic and we're given this function already. And we want to find domain, range, increase, decrease, intervals, max, and min. So we're going to come in here and figure out our domain. Our domain talks about our x values. So we're looking for our smallest x value and our greatest x value using our x-axis and our x values. Our smallest is going to be at negative infinity because this line is going to keep going and it's going to keep getting bigger and bigger and bigger, or smaller, I should say, as it goes left on the x-axis. So it's going to go all the way to negative infinity. Then on the other hand, on the other side of the graph, we have this line keep on going all the way to the right on our x-axis. So it's going to keep going all the way to positive infinity. We use parentheses instead of brackets because we cannot break in infinities. Just never can. An example that I gave you, or a way to remember it during class, is that the round part of the infinity matches up with the parentheses. Now going on to range. Range talks about our y values. Our y values, looking at our y-axis, that up and down axis. Kind of like our x's, this graph is going to keep going down all the way to negative infinity. So our smallest y value is going to be negative infinity. But as it goes up, as the graph gets further up, it stops. There's not a bigger y value than right here. Well, that value is roughly at 8.2. Then we're going to close the bracket and not use a parentheses because it is included. There is a point there. So now I'm going to erase it. Pause if you need to. That's why I've got the videos. I'm going to erase everything so I can see the graph again. So now we're talking about increase, or where the y values are increasing. Starting over here, left to right, going up, so we're increasing, but right at this line, we're going to change directions. So we're starting at negative infinity, and we're going to this x value right here, which is roughly 3.5. We're going to bracket that in. So that is going to be our increasing interval. Now let me change colors. So now we're looking for where we're decreasing from that 3.5 x value all the way down. We're decreasing all the way down. We're decreasing. So we're going to start at that positive 3.5, but then we're going to keep on going down, and slowly all the way over to the right to where we get positive infinity. Again, I'm going to erase what I wrote so I can get to the graph easier. So then we have our min and our max. We don't have a small point down here, or an exact point, that is our smallest point, because these lines keep on going forever and ever and ever. So we have no min, or none, but we do have a max. We do have a highest point of our graph. This point is a location, and it is roughly at 3.5, 8.2. And there's our max. Then we go on to the next one, and our graph is already given for us. So we're looking at our domain, range, increase, decrease, x-intercept, and y-intercept. So first we want to do our domain. Our smallest x value is going to be right at this +4. There is a dot at 4, so we're going to include it. So there's a bracket. And then it keeps going forever and ever and always. So it's going to go to +infinity. And then we look at our range. Our smallest y value is found here at 1. There is a dot at 1, at y value 1. So we're going to bracket in. Then as the graph keeps going, it slowly goes up, 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 up. So we're going to go to +infinity. So I'm going to erase what I wrote so I can get to the increase and decrease. Is there any place where this graph decreases? No. So we can put none, or no, or NA. Somehow tell me that it is not decreasing. Now increasing, it is increasing. The whole graph is increasing. So we are going to create that interval. The x value where it starts to increase is at 4. Again, there is a dot at 4, x equals 4. So we're going to bracket in, and then it keeps on increasing forever and always. So we're going to have an infinity, positive infinity. Then we're asked, is there an x-intercept or y-intercept? There is not. So we just put no or none for both. Then we get into our transformations. State which way the graph shifted after the translation from the parent graph. So our parent graph in this is our absolute. X equals the absolute value of x. So what is in the inside with the x? Remember, we're going to scrunch down and we're going to be disobedient to our parents or whoever's telling us what to do. So we're going to be mad at them. We're not going to do what they say. If we're in the inside, we're also affecting the x's. So if we affect the x's, affect x's, we're going to go right or left. So with this -1, we're going to be disobedient. So we're going to go to the left 1. Now this -3 is on the outside. If it is on the outside, away from the x, we're good little children. We're going to be obedient, and we're going to affect the y's. So if we affect the y's, then we're moving up or down. So because we're good little children, we're going to be obedient. That negative is telling us to go down 3. And there is our translation. Our next one. If I'm going too fast, pause the video and copy it down so you can practice. So our parent is our square root. Y equals the square root of x. This 3 is on the outside of the x, so it's affecting the y's. It is going to, the 3 is going to stretch our parent function by 3. This positive 2 is on the outside, so it's going to affect the y's. We're going to be good little children and be obedient to the sign. So this is going to tell us to go up 2. So there is our translation. And transformation. And then lastly, our parent function is absolute value again. On the inside, we have plus 3. Inside is disobedient. We're affecting the x's. Instead of going to the right for positive, we're going to go to the left. Again, because it's inside. So we're going to go left 3. Then we also have this 1/3 outside, not with the x, not right beside it. So that 1/3 is telling us to compress by 1/3. And that is our transformation from our parent function. If you have any questions, do not hesitate to email me. I want you to be as prepared as you can for this quiz. If you don't know already, my email is Taylor Massey at johnston.k12.nc.us with no spaces.